friends. This is Eli from Mystic Circuits, and today I am very happy to be able to share with you a module that I've been working on for almost 5 years, 3D VCA. 3D VCA is a quad VCA in 6HP that is designed to accomplish a wide variety of mixing, crossfading, panning, and routing possibilities. Instead of having individual control over each VCA, you use the three macro controls X, Y, and Z to control the VCAs together as a group. X, Y, and Z shape the entire group as if the parameters were a point in three-dimensional space. 3D VCA can be used in mono, stereo, and quad. It is designed to daisy chain together through the sum inputs, which allow it to place nicely with other stereo and quad VCAs or mixers. 3D VCA uses high-quality sound semiconductor 2164 ICs and op-amps with rail-to-rail inputs and outputs to allow extra headroom when mixing many signals together. While 3D VCA is designed with audio as its focus, all inputs are DC coupled, and so slower control voltages and even voltage sequences can be blended together using its mixing matrix. Whether 3D VCA becomes your main mixing solution or best friends with your other multi-channel mixers, you will be impressed with what 3D VCA brings to the table. As mentioned before, 3D VCA uses the macros X, Y, and Z to control all four VCAs simultaneously. X controls the activity of the left and right pairs of VCAs, Y controls the activity of the top and bottom pairs of VCAs, and Z controls the activity of all four VCAs. In this way, by controlling X and Y, you can pick out any of the four channels individually, any adjacent pairs of channels simultaneously, or have on all four channels at the same time. After the X and Y settings are selected, then the Z parameter will gradually turn on or off whichever VCAs are currently within that selection. The circular compass window between the X and Y knobs shows you the activity of all four VCAs, depending on the settings of both the panel controls and any incoming CV. You can see here with X and Y in the middle, the entire circle is illuminated, meaning that all four VCAs are on. Turning up and down the Z parameter will turn on or off all of the lights simultaneously, indicating that we are turning on or off all of the VCAs simultaneously. With Z set all the way up, changing X will turn on or off the left and right pairs of VCAs, along with the left and right sides of the compass circle. And changing the Y parameter will turn on or off the top or bottom VCAs, along with the top or bottom of the compass circle. Changing X and Y together will activate each corner of the compass individually, and as a shorthand, I will be referring to each VCA as their intercardinal compass direction, where the top left is the northwest VCA, the top right is the northeast VCA, the bottom right is the southeast VCA, and the bottom left is the southwest VCA. And just to reiterate, in any of these settings, the Z control will affect the overall level and should visibly change the brightness of any LEDs that are still active. Both X and Y use what is called an equal power distribution curve, meaning that the volume should remain roughly the same when mixing and crossfading between multiple sources. In contrast, the Z parameter uses a linear response to be as predictable as possible with a variety of control voltage sources. Keep in mind that human perception of sound is actually not linear, but logarithmic, so it might sound like the volume turns up faster towards the bottom of the Z slider than towards the top. This is not your imagination. Both the inputs and the outputs of 3D VCA are laid out in a square, which corresponds with their direction in the display compass. This should make things as easy as possible to keep track of. For example, the northwest VCA has its input in the upper left of the input square and its output in the upper left of the output square. The northeast VCA has its input in the upper right of the input square and its output in the upper right of the output square. Southeast has its input and output in the lower right, and southwest has its input and output in the lower left. Both the input and output squares have their own normalization scheme, which is shown using arrows going between the various input and output jacks. You might notice that the normalization is different between the two squares. The main reason for the strange normalization is to make stereo patching intuitive, with the left and right inputs and outputs corresponding to the left and right channels of a stereo signal. This normalization scheme also allows a mono source plugged into the left side of its VCA pair to be distributed to its right side, allowing the mono source to be panned or combined with stereo signals without requiring any other modules. In addition, this normalization scheme distributes one signal to all 4 VCA inputs by plugging it into the northwest input, or for 4 signals to be mixed down together to one output by plugging out of the southeast output. The final feature to point out on 3D VCA is the summing input section found on the left side of the panel. These inputs allow external signals to be automatically mixed into each of the 4 outputs, enabling multiple mixer modules to be daisy-chained together, or for 3D VCA to act as a unity mixer. Since there was not enough space on the panel to have another square of jacks, all of these inputs are labeled with a white square pointing in the direction of the output that they sum into. For example, the top input sums to the northwest output, the second input down sums to the northeast output, the third input down sums to the southwest output, and the fourth input or bottom input sums to the southeast output. When using 3D VCA in stereo, each pair of sum inputs will be treated as its own stereo input, with the left channel on top and the right channel on the bottom, meaning that 2 other stereo submixes can be automatically mixed into the final stereo output of a single 3D VCA. The sum inputs are especially useful when using 3D VCA in quad. Taking each of these outputs and plugging it into the corresponding sum input of another 3D VCA allows an entire quad mix to be made using only 3D VCAs daisy-chained together. This also means that you can expand your quad mixing capabilities indefinitely by simply adding more 3D VCAs to your system. How convenient. As mentioned before, these inputs can also be used as a unity mixer that can combine up to 4 external signals with the outputs of 3D VCA. In the example from before, where we are crossfading between 4 individual inputs and mixing them together coming out of the southeast output, we are able to add all 4 sum inputs to the southeast output as well. And this means that a single 3D VCA is able to mix up to 8 audio signals together with voltage control over 4 of those signals. While stereo is becoming more popular in Eurorack, most sound sources that we deal with are mono. However, sometimes there are multiple outputs of a sound source like an oscillator, filter, something like that has different shapes or tones, and we'd like to be able to blend them all together. 3D VCA is perfect for this and lends itself nicely to mixing up to 4 different audio signals together under voltage control. Here, I have one of my favorite examples of a use for this. Next to our 3D VCA is the lovely Qubit chord module, which is a quad VCO with voltage control over the voicing and characteristics of a chord. The chord module has 4 individual outputs for each of the voices in the chord, but also has a handy mix output, which simply mixes all 4 voices together. Many times when writing music, having a lot of 4-part harmony can get overwhelming a bit quickly, and 3D VCA helps us solve this by allowing us to pick out various bits of the harmony and modulate which sections of the chord we're going to hear, even allowing different notes to have different volumes. Here, I have all 4 of the individual outputs of the chord going into the 4 inputs on 3D VCA. And you can see that with both the X and Y in their center positions, we're able to hear all 4 notes. If I move X or Y, we sort of pick out different pairs of the notes. And if I set X and Y to their limits, then we're able to pick out each individual note in the chord. Now, if I run an LFO into both X and Y, you hear things start to get a little bit more interesting. We're getting a sort of evolving polyphony instead of just a static chord. It's all still based on the same information. If I run a voltage into the voicing of our chord, and then we'll run an envelope into the Z input, in order to give it a more percussive feel, then we start to get something that feels a little bit more musical. And that's not all. What I'm going to do now is I'm going to start to plug things into the sum inputs. So here we have our quad drum. It already has everything. It has its own mixing capabilities, and all of the drum sounds have their own envelope and VCA built in. So it's nice to be able to run something into one of the sum inputs that doesn't need its volume controlled, right? The 4 voices going into the main VCA inputs all require a bit of modulation, whereas the quad drum has its own modulation built in. I'm going to run a couple of other percussive elements that I have into the sum inputs. Here I have a mutable instruments rings, just kind of making a little plucky sound. I have a self-oscillating filter, being the IFM Sprott, which is just being like a pinging filter, kind of a gong sound. And then we have our plats, which is also making a percussive sound. So now, in this scenario, you're able to see the power of 3D VCA. We're able to use all 4 VCA inputs to do some interesting modulation of a particular voice that benefits from having external volume modulation applied. And then on top of that, we can mix 4 other sources that could just go into the Unity Mixer section of the module. It's a lot for such a small module to do. I'll go ahead and show you some other useful examples for this technique. So in this patch, we are using 3D VCA with a classic analog oscillator called the Variable Waveform Generator from Sputnik Modular. It has 4 classic oscillator waveforms as well as a sub-oscillator, but they're all on separate outputs. Now, I'm going to turn the volume up. You can hear that we have a sine wave coming in to one of these sum inputs, but as I turn the volume of 3D VCA up, you can hear us mixing in the other 4 outputs as well. Now we're running all 4 of these outputs into the 4 inputs of 3D VCA, and as we change the X and Y, we add in one of these 4 outputs, or all 4. Now I'm using the sine wave into the sum input because we're sort of able to control, like the sum is like the base signal of our patch, and then we turn up Z in order to add a little bit of spice to the patch, right? And then we're also able to change X and Y to decide if we're adding more like salt or pepper, you know? But then as we turn Z down, we go back to the base oscillator waveform of our patch. Now we have the output of our previous patch with the mixture of different oscillator waveforms going into a filter. In this case, it is one of my favorite filters, the IFM Sprott. This is a state variable filter with a separate low pass, band pass, high pass, and an extra weird chaos pass output. Maybe you only sometimes want to hear the chaotic output, or maybe you just want to smoothly be able to morph between the low pass and high pass modes of this filter, but by plugging all 4 of the filter outputs into the 4 inputs of our 3D VCA, we're able to smoothly morph between them. So I'm going to go ahead and turn up our 3D VCA. We have the sine wave going into the low pass of this, and I have a little bit of resonance, so we're able to hear it a little better. You're also able to morph to the high pass now. There's the chaotic resonance kicking in, and then we can move here to like the chaos pass. Does some weird stuff. And again, you know, now we're hearing all 4. You were able to increase the Z slider on the other 3D VCA, and now we are mixing all of those waveforms together going into our filter, right? And then you can change which of the filters we're listening to. I'll mess with the cutoff just a bit. There you have it. In this final section of the patch, I wanted to show what it looks like to use 3D VCA in order to blend between 4 different effects modules. We are taking the output of our previous section with the filter, and then running that into a passive mult, which is going to our 4 effects, and then the output of the 4 effects is going into the input square on our 3D VCA. I'm also taking the dry signal and running it into the sum input at the bottom of the module in order to carry our dry signal through to the output, and that makes it similar to the way that we were treating our oscillator 3D VCA, where when Z is all the way down, we have a totally dry output, and when we increase Z, we're adding that spice back into the patch. So if I turn up the volume of our filter 3D VCA, it's off screen, but you can hear I'm still able to go between all the different filter responses. And then I turn up the Z slider on our effects 3D VCA. You can hear that I'm able to smoothly transition between our 4 effects. Some of them are more noticeable than others, so And again, I have access to all three of these 3D VCAs, so I can turn up the Z slider on the Waveform 3D VCA and introduce some of those more kind of interesting oscillator waveforms. I can mess with the X and Y on the filter 3D VCA and get all of those more interesting filter responses, and then I can increase C and mess with the X and Y parameters of our effects 3D VCA and get all of those more complex effects. Now, you can imagine this isn't a super musical example because I'm just running a tone into a filter and a bunch of different effects. There's no note sequencing or modulation going on. But if you were to take this and treat it like a voice, it gives you a lot of different parameters that you're able to use and different ways of using modules that might already be sitting in your patch, but that you're not using the other outputs. So for example, with our filter, maybe before I would have only used the low pass output of that filter. Now you can take all of the outputs and you get access to them without having to repatch, right? And so you can imagine using a little bit more modulation, using these effects somewhat sparingly, you could actually get really interesting results by just adding a 3D VCA into your patch. In my humble opinion, using 3D VCA in stereo is where this module really shines. You might notice that X, Y, and Z all have these small labels next to them. These labels refer to how these controls function in the standard stereo patching setup that I'm about to show you. In this configuration, 3D VCA is able to crossfade between two stereo inputs using the Y control, balance the left and right channels using the X control, and set the overall volume using the Z control. When we are working in stereo, we treat left and right inputs and outputs on the 3D VCA like the left and right channels of our stereo signal. A useful trick is that even if you are using a mono signal in this stereo context, if you plug the module into one of the left or west inputs, it will distribute the signal across to the eastern input for that row. And you'll be able to pan, crossfade, or combine it with other stereo signals, just generally being able to treat it as if it was a stereo signal. This is why 3D VCA employs this unusual normalization pattern, where the inputs normalize from left to right, but the outputs normalize from top to bottom. We want a mono signal to be able to take up both left and right channels of a row, but we want our stereo outputs to mix downwards into two columns. As we can see from the normalization pattern on our panel, which are the arrows that connect the inputs and outputs together in each of their squares, when northwest and northeast are unplugged, they will mix downwards into the southwest and southeast outputs. Similarly to the control labels that are next to each of the controls, there's a little label down here. It's hard to see on camera, but it signifies that these two outputs are the main stereo output. And I'm going to go ahead and patch that into our output module. The left output, double check that that's what I'm doing, is the southwest output on 3D VCA, and southeast is the right side of our stereo signal. Next, we'll go ahead and patch in a stereo source. Here I'm using the Make Noise Morphogene, which is wonderful because it plays back loops in stereo. Again, left channel, southwest, right channel, southeast. I usually like to start patching in all scenarios, but in this in particular, starting from the bottom. This is because most of the normalization connections go sort of downwards on 3D VCA, and so if you start patching from the top and then patch something into the bottom, you can get some volume jumps or maybe some clicks. So I patch into the bottom first in order to avoid that. I'll go ahead and turn our signal up. You can hear we have a little loop coming from the Morphogene. This is just one stereo signal. I have one of the channels going into a mult and then into the mutable instruments rings, which has also a stereo output. Only mono input, but it has a stereo output. And so you can hear we have a second stereo signal being mixed in now, and in this point in the patching setup, all of these labels that are on the knobs will correspond to what the function is within this patch. So Y is going to crossfade between these two stereo signals. You can hear here we have the resonator output, here we have just the dry morphogene output. So this control is now behaving like a wet-dry for a stereo effect. X will again pan between the right and left sides of our stereo field, and then Z will behave like an overall volume control. So you should already be able to see how powerful this sort of setup is, just modifying it by hand. But once I introduce some control voltages, you can see the real potential. Here I am going to put in an envelope into Z to control the overall volume. And if I want to make it so that even when the envelope is fully down, you're still able to hear a little bit going through, I can go ahead and increase the Z a bit just to bring the overall volume level up. Next, I'll patch in an LFO to Y, which you should be able to hear is sort of blending between the dry and the wet version of that signal. And then finally, I'm going to patch in a random stepped voltage into X. This stepped voltage is coming from the Ohmi Industries cascading register, which is being clocked with a multiplied version of the end of slice gate coming from the morphogene. So every time a slice plays, it sends out a couple random voltages, and that, in this scenario, is doing some random panning for every slice. Now, if that wasn't enough for you, we can still patch in a second stereo signal. Here I'm going to go ahead and put in the VPME quad drum, which has a stereo mixer built in, and which nicely is able to maintain its own stereo image when we patch it into one of the sum inputs. So I'm going to go ahead and take the right output of our quad drum, patch it into the northeast sum input. You can hear it's already starting to pass its audio along, and then we're going to take the left output and patch it into the northwest sum input. You can hear that this stereo signal is just being automatically mixed into the output of 3D VCA with no other modules necessary. It's sort of arbitrary whether or not you pick the north or south inputs, but because I'm about to patch in a second 3D VCA, I wanted to keep the naming convention the same between them. So I'm going to go ahead and take our second 3D VCA, and you can see here we have an open stereo input. So I'm going to take the southeast 3D VCA output and patch it into the sum input for southeast. And then I'm going to take the southwest, patch it into the southwest sum input, and you can hear as I increase the volume over here, we have a mutable instruments Platts, which is also being sent through along to the output. Let's go ahead and shift gears for a second and focus on this second 3D VCA. So here you can see another way to use 3D VCA in a similar patch as before, but where it's being fed by only one module that doesn't use stereo outputs. Platts has two different outputs, which in most modes give two different flavors of the algorithm currently being used, but which don't necessarily give you a stereo image or a mixture of those two outputs. Here we have the left output of Platts being plugged into the northwest input on 3D VCA, and the right output of Platts being plugged into the southwest input on 3D VCA. As mentioned before, this will distribute those signals across both of the inputs in that row. So northwest is being distributed to northeast, southwest is being distributed to southeast, and that will let us treat these as if they were stereo signals. Just like before, we're able to control the level to crossfade between both of these inputs. So here we can hear in chord mode, it's just giving us a sort of bass note, and then this gives us all of the extra notes in that chord. And then again, we're able to pan using X. This means that we can take a mono source with multiple outputs and pan, crossfade, and level it, just like we did with the stereo outputs earlier. Now, there's one more thing I'd like to mention about this patch, which is that all of the sum inputs on our second 3D VCA are still totally open. This means that all these inputs will be added into the final mix on our first 3D VCA, just like the output of this 3D VCA is being summed into the final mix. This means we can have up to 2 more stereo signals coming in without involving any more mixing modules. And if one of those stereo signals is coming from another 3D VCA, then really the sky is the limit for how many signals you could mix together using this technique. Now, if you mix a lot of loud signals together, you're going to end up dealing with some clipping at some point in the chain. But 3D VCA is made with high-quality op amps that have rail-to-rail inputs and outputs, meaning that they should be able to go all the way up to the voltage limits of your power supply before clipping. This gives your modules the maximum amount of headroom to be as loud as possible while mixing multiple signals together. However, there are always limits to these sorts of circuits, and plugging 3D VCA into another module that doesn't have rail-to-rail op amps can clip the other module. So just keep your levels in mind when mixing together a lot of signals using this technique. Now, just to show you another example of the utility of the sum input daisy chaining technique, I'm going to go ahead and plug a third 3D VCA into one of the sum inputs to show a patch where 3D VCA is controlling the volume of only one sound source. Here, our first 3D VCA is still controlling the volume of our morphogene and rings resonator. The second 3D VCA is controlling the volume of our Platts oscillator, and the third will control the volume of our qubit chord. As you can see, each 3D VCA is plugged into the next unit's sum input using the southeast and southwest outputs going into the southeast and southwest inputs. And this allows us to automatically mix the output of each module down the line. We also have the stereo output of our quad drum being mixed into the first 3D VCA just like before with no modulation coming in. You can see we're able to use 3D VCA as a sort of mixer, with each one being like a mixer channel and the Z controlling the overall volume of the channel. X will control the panning, so we can have different panning for each module. And then Y is some sort of timbre altering control where you're able to crossfade between different outputs of a module or control the dry wetness of something like that. So this can be treated like a sort of distributable, expanding mixer, with each voice getting its own mixer channel. As you can see, 3D VCA excels at mixing in multiple ways. If you have a small system or limited funds and you want a compact module to mix everything in your case together in mono, then a single 3D VCA will go a long way for you. On the other hand, if you have a large case with many voices and an emphasis on stereo signal flow, then using one 3D VCA per voice and daisy chaining them will give you a streamlined and effective way to level, pan, and crossfade each voice with voltage control. You can have your mixing pre-patched by leaving the 3D VCA sum inputs tied together, and even have your 3D VCA mixer channel right next to the voice that it is controlling. If you want to go somewhere in the middle of these two paradigms, using only 2 or 3 3D VCAs will allow you to mix a lot of stereo signals together with easy crossfade and leveling controls, either manually operated or fully voltage controllable. As an example of a more focused way to use 3D VCA, let's take a look at using it to send or receive audio using some stereo effects. Here I am again using the Make Noise morphogene for our audio source, which is sending a stereo loop to our first 3D VCA here. This 3D VCA is patched a bit differently than before in order to distribute a stereo signal to 2 different destinations. This is because of the unusual normalization scheme for 3D VCA, which distributes its inputs from left to right. Here we need to send our left channel into the northwest input on 3D VCA and our right channel into the southwest input on 3D VCA. Then we take the western 2 outputs and plug them into our first effect, which is the mutable instruments beads. And we take the eastern outputs and plug it into our second effect, which is the qubit aurora. As a small side effect of patching like this, the X parameter now controls the distribution of audio being sent to each effect, whereas the Y parameter now controls the panning of the audio being sent to each effect. There's a reason that I labeled these as X, Y, and Z instead of having hard and fast descriptions of the functions for the 3 parameters. Sometimes what each control does is different depending on how it's patched due to the flexibility and routing of 3D VCA. If you didn't follow this, don't worry. I'll have notes on all of the most useful ways to use 3D VCA listed in the patch examples of the written manual. Now returning to our patch, again the western outputs of 3D VCA are going into a mutable instruments beads, and the eastern outputs of 3D VCA are going into our qubit aurora. allowing us to use this 3D VCA to determine the send levels of our source as well as its destination. Then we have a second 3D VCA, which is mixing the stereo outputs of both of our effects together, with the northern inputs being plugged into the mutable instruments beads and the southern inputs being plugged into the qubit aurora. And this is the same as the previous examples of how we were using the stereo patching. Now, I'm also using a mult in order to mult the dry signal of the make noise morphogene into the sum inputs on our second 3D VCA. This is so that we're able to listen to the dry audio of what we're processing. It gives us an idea of how we are doing the process, even though this doesn't work strictly like a wet-dry control because the dry is always on. We do get a wet control with the Z slider and a select control which goes between the two effects, and a final panning control which allows us to do some stereo imaging. So now I'm going to go ahead and turn on the audio. This is just the dry audio, and then I can go ahead and turn up our first 3D VCA, or rather the second 3D VCA, which is controlling the receive level of both of our effects. We still don't hear anything because we need to turn up our first VCA to increase the send level of both effects. And now you can hear the sort of time-based effects being mixed in, right? Now, again, we can use the Y control on our second 3D VCA in order to determine the crossfade between both effects. So this is now selecting only the mutable instruments beads, and this is now selecting only the qubit aurora. And then no matter what our patching situation is, we can also change the panning of the affected audio, and again turn down the wet level, right? So with wet all the way up, we can also start to mess with our send 3D VCA. So we have this controlling the amount of send, and with time-based effects like this, turning off send quickly will allow the tail of those reverb and delays to ring out so that you can get just little bursts of audio coming into these effects, which can be a bit more interesting than just turning off your wet signal altogether. Then again, we have the distribution of where the audio is being sent being determined by the X control. So now we're only sending audio to the aurora. And I'm going to go ahead and turn the timing up on this reverb and switch the send over to the beads. You can hear the aurora slowly decay away, whereas if we were to do that with just the second 3D VCA, we would be able to do it immediately, like that. And of course, using Y, we can select whether or not we are sending audio just to the left or right channels of our stereo effects. Now, because both of our effects are time-based, we can also get some interesting results by just leaving the second 3D VCA's Z level up, acting as the wet volume control, and just altering the levels on the first 3D VCA. So I'm going to go ahead and send some LFOs into the voltage control parameters of our first 3D VCA. And you can hear that we're getting all of these different ways of sending snippets of our audio to different time-based effects in order to have them smeared, delayed, and reverberated in parallel. And this makes it so that you're able to get a much more interesting way of interacting with these effects rather than just having them all on all the time. You're able to send little bits here and there. I can even take a fourth LFO, plug it into the Z for the final wet control. You can hear it mixing in and out the final output of those effects as well. So with voltage control, I think that you can see how powerful such a setup can be. We get a lot of different ways in order to manipulate where audio is being sent, and this sort of unlocks some hidden potential from the effects that you already have in your rack. Now, another advantage of using 3D VCA with effects is that it can add either a dry wet or a feedback control to stereo effects that do not have one included. For better or worse, all of my stereo effects have dry-wet controls built in, so I'm going to go ahead and show this using a module which is not specifically designed for stereo, but which does have parallel audio processing capabilities, which is the IFM Sprott. Again, this is a state variable filter with multiple inputs and outputs for the different filter types. So we'll go ahead and send our left channel into the high-pass filter and our right channel into the low-pass filter. So I have our make noise morphogene again acting as our stereo audio source. I have the left channel going into the southwest input and our right channel going into the southeast input and also into a passive multiple. I'll go ahead and turn that audio up. The same loop you hopefully haven't gotten sick of yet. And I'm going to go ahead and take the multed outputs, put the first channel into the high pass input, second channel into the low pass input. Then we'll go ahead and take the high pass output, plug it into southwest, low pass output, plug it into northeast. And then if I change the Y, you can hear that we have the filtered version of that signal showing up towards the when Y is up. And turn it down. We have our clean signal. Turn it up. You can hear it's sort of resonating. That filter should be different in both ears. So another use, as I mentioned before, for 3D VCA is to add feedback to effects that don't normally have it. Here we're going to go ahead and use the Qubit Aurora in order to showcase that. You can imagine feedbacking a reverb. It gets pretty wild pretty quickly, but this one has some interesting tricks up its sleeve when you put in some feedback. So you want to kind of imagine how we would get feedback. What we would probably want to do is we would want to take our normal input signal, crossfade that with the output of the Aurora, and then have that going back into our Aurora. So in order to hear it, we're going to go ahead and take the outputs of the Aurora, plug it into our passive mult, which is also plugged into our output module. So now we have the output of Aurora being multed. Then we'll take the output of our first 3D VCA, which still has the stereo patch from before, plug it into the southwest and southeast inputs of our second 3D VCA. Next, we're going to go ahead and take the southwest and southeast outputs of our second VCA, plug it into the left and right. I'll turn the volume down just for a sec. Left and right inputs of our Qubit Aurora. And then you can see here we have just the normal signal coming from our first 3D VCA going into the Aurora. In order to add the feedback, what we're going to do is we're going to take that multed output, plug it into our north inputs, and then you can hear as we increase the Y, we're starting to get some self-oscillation, right? Takes certain notes and smears them quite a bit. If we increase Y to noon, we're getting a pure mixture of the feedback and of our input. And then if we increase Y all the way, we're getting only feedback. You can hear it start to evolve. If I do some stuff. Isn't that cool? And the nifty thing about all of this is that you can turn Y down, go right back to the patch that you had before where just the input was happening. Just the input was going through the Aurora. So something that I like to do is to run a gate into that Y input in order to just add feedback for little snippets, right? And what this does is it takes chunks of your audio, uses that to seed the feedback. And so every time you start the feedback, it actually ends up in a different place. Feedback doesn't just care about what your signal path is, it also cares about how you got to the place that you are. So if we change the audio going through at the point where we kick in the feedback, that'll give us different sort of effects. I could also, just for fun, plug a gate into the Y on our first 3D VCA, use it to mix in that filtered signal. we start to get something pretty interesting, and this is maybe a little bit noisier than some of you are used to, but I think it's still a good example of using 3D VCA to add both dry wet to a filter or any kind of stereo effect that doesn't normally have it, and also to add feedback in that scenario. And it also shows ways in which, with just like a passive mult, you can get a whole lot of extra capability out of the 3D VCA that just doing it in the box would not necessarily be able to accomplish. 3D VCA stands among a small number of modules that are designed to work in quad. For those that don't know, quad refers to making music with 4 unique audio channels instead of the standard 2 channels used in stereo. Instead of making music for just your left and right ears, you can make music that's assigned to the front left, front right, back left, and back right speakers, making your audio go all the way around your listening vantage point and creating a rudimentary surround sound. It's difficult to show the results of working in quad because people watching this video will most likely not be watching it on a surround sound system. So we're going to go ahead and fake it a little bit. I have the 4 outputs of our 3D VCA patched into the 4MS SISM, which has some level indicator LEDs for 4 channels. So whenever there's a channel present there, it will light up. And then I'll go ahead and apply some filtering and reverb to 2 of the channels to make them sound like they're further away. Later on, I'll hopefully be able to upload some examples using quad to our YouTube channel so that people with surround sound systems will be able to appreciate how 3D VCA works in quad. YouTube apparently does support surround sound, but for now, please just use your imagination. So right off the bat, we have an oscillator being our mutable instruments Platts, which is going into the northwest input on 3D VCA. As shown before, the northwest input is normalized to all 4 of the VCA inputs, and you can see this a little bit with our normalization pattern. From here, we can turn up the level of our Z control, and with X and Y both at noon, you can both see and hear that we have all 4 channels going on. Next, if I move X or Y, I'll be moving to the left and right, and then Y will be moving forwards and backwards, and you can sort of hear the difference between the two. Now, if I do X and Y, we're moving to all 4 corners of the square. This can be used in mono as well if you want to simply send the signal to 4 different effects or destinations, but the operating principle for using our module in quad is the same. From here, we can go ahead and apply some CV to the X and Y inputs. I'm using the 4MS, or rather the Mutable Instruments Tides in phase mode, and the nice thing about this is that it will apply an LFO, 2 different LFOs that are in phase or out of phase with each other depending on the shift level setting. And if you watch, if I change the phase control, you can see our signal bouncing around in all these different ways. And if we can get the phase control so that these 2 LFOs are roughly out of sync with each other by 90 degrees, then we are roughly moving in a circle around us. Now, if you have a quadrature, oscillator, LFO, or an oscillator with both sine and cosine outputs, it'll be easy enough to achieve the spinning in a circle effect around us. But having a variable phase on tides is really nice for being able to experiment with other sort of wonky, lopsided shapes. As you can see, now it'll jump through the center before going to the other side. And we just get all these interesting lopsided orbits for our signal. Another advantage of using 3D VCA in quad is that it does not require any additional quad mixing modules. We can simply use the sum inputs on all of our 3D VCAs in order to automatically mix quad throughout our entire synthesizer. Now I'm going to go ahead and take the outputs of this second 3D VCA and patch them into the sum inputs of the 3D VCA we had patched up before. And it's important at this step in the process to keep the inputs and output compass directions matching, and that just makes it so that the controls will behave predictably and the same between all the different modules. And then I'll go ahead, turn up the Z. We have a little drum loop. We can make it go in front or in back of us. We can pan it left and right. And of course, we can do the overall volume. And this is completely independent from our first 3D VCA. We can have that go in front or in back. We can have that go right and left. And we can set the overall volume. And again, this is totally independent between the two, right? So we could have different panning. We could have one going in front or in back. Or in this case, I'm going to go ahead and patch some LFOs into the X and Y and get these sounds sort of spinning around us. It's tough with these right angle cables sometimes, but it's important to be able to see what you're doing. There we go. Now we have our mutable tides, both of these sound sources in quad all the way around us and doing them independently of each other. And of course, this entire time I can individually control the volume for each of these channels, right? So not only do we have quad panning control of all of this, all of our audio sources, but we also have quad volume control. And a nice thing about this is we can use it with other modules in quad. 3D VCA plays nicely with other quad modules by either taking the quad output, patching it into the sum inputs so that it's mixed into the chain, or by actually processing that quad audio, patching all 4 quad inputs into the input square, and then using 3D VCA's volume and balancing controls in order to affect the audio that's coming through. Now I have one last example of using 3D VCA in quad, and that is by using 2 of them together in order to emulate a quad crossfader. You can see this patch is pretty complex, but I'm going to go ahead and explain everything piece by piece. We have our 2 3D VCAs, which are summed together using the outputs of one 3D VCA, patching it into the matching sum inputs of our second 3D VCA. Then I have mutable tides, which is modulating the X and Y of both of them, and I've multed the 2 LFOs that we're using for X and Y so that it's sharing the same sort of direction orientation between both of them. Finally, the signal that we're crossfading are 2 outputs from our mutable plats. Both outputs are going into the northwest input on each of the 3D VCAs, and in order to control them, I have a 4MS SISM, which is being used as a voltage offset, and then I'm inverting the voltage of one of the outputs in order to modulate both of the 3D VCA's Z parameters. And by inverting it, that lets me make it so that when one 3D VCA is turning on, the other one is turning off. And in order to complete that, I have the Z sliders for both 3D VCAs in their opposite position. So I'll go ahead and turn that up. You can hear the signal is moving around in front and in back, left and right. If I turn up the voltage offset, you can see that only one of the 3D VCAs is on, and then I can turn that down. Now only the other 3D VCA is on. Back and forth. And of course, if we wanted, we could plug in a voltage in order to modulate this effect. So this patch is pretty complex, but it's just one of many examples that you could find for a much more intricate way to treat quad audio using 3D VCA. As mentioned earlier, 3D VCA is fully DC coupled, meaning that it has a variety of uses in the control voltage range. Here, I am sending 4 voltage sequences into our first 3D VCA, which is crossfading between all 4 of them, taking the output into a quantizer, and then that quantizer goes into an oscillator, in this case our mutable instruments plats. Now we have our 4 gate sequences going into a second 3D VCA, which is being sent into the Schlappy Engineering Boundary, which is a combination envelope and VCA. A particularly nice thing about the boundary in this use is that the boundary has an input which allows you to have different amplitude envelopes based on the amplitude of the trigger coming in, so it gives you a sort of fake velocity sensitivity. Finally, we have a third 3D VCA, which is taking an LFO and either turning it off or sending it to 4 different modulation destinations. And a nice thing about this is that we can avoid the sort of seasick feeling of having everything being modulated at once. You get to sort of pick and choose which places are being modulated or take modulation out of the patch completely. So as you can see, as we change the X and Y settings, we are able to crossfade between these different sequences. And of course, if we do X and Y all the way to the extremes, you can hear the sequences by themselves. And then as we go somewhere in the middle, you get something that isn't necessarily the transposition of both of the sequences as much as a blend of the two. And that's because the level of one sequence, the overall voltage level is going down as the level of the next voltage sequence is coming up. We can also change the entire range of the sequence by turning down the Z slider or turn off the voltage sequence completely. And we can do a similar thing with our gate blend. So here I'm able to just play each gate sequence by itself, or I can do something sort of in the middle of 2 gate sequences. You can hear at the end there, we're getting quieter notes, and that's because the level of the triggers going into the boundary are lower. And also an interesting effect of this is that when the 2 gate sequences overlap, you'll get a higher amplitude than when you only have it at one or the other. So you can actually get multiple levels of gates by going in this, using this technique. We can also turn down the level of the triggers to change the overall amplitude or to mute our sequence. Finally, I'll show you the LFO. If I turn this up, you hear that we start to get some modulation. If I go to each of the corners, once again, we are only modulating one aspect of the patch. And then if I do some kind of blend, we get to modulate a whole bunch of different parts of the patch. Or to turn off modulation completely. Something that's nice about this is that, again, all of this is under voltage control. So I'm going to go ahead and take some random voltages, again, from the Omi Industries cascading register. And I have a gate that sets up a random voltage every time that we start a measure over. So now we're randomizing the note sequence once per measure. Going to send a voltage into the gate sequence so that we're also randomizing that. And I'm going to send one of the random gates into the Z for the modulation. So you can hear that when that turns on, we're enabling modulation. And then I can also send gates into the X and Y. I'll turn down X and Y so that we get a sort of like combination of the 4 different positions, and then we're randomizing the destination for our modulation as well. The final patch that I'll be showing you using 3D VCA is a recreation of the classic sound that got us all into modular synths in the first place, the wobble bass, and this patch is for you, David. So in order to make our wobble bass, I have 2 3D VCAs which are controlling the modulation for our entire patch. Our first 3D VCA is crossfading between 4 tempo synced LFOs, which are coming from our mutable instruments tides. We have a clock sequence going into the clock input on tides in order to keep everything everything in time with our gate sequence, and also to sort of shuffle around the speed and the timing of this LFO. Then with 3D VCA, we crossfade, a sort of blend of these LFOs in order to get something a little more complex and to switch between the different speeds. And we send that out of our southeast output. That then goes into the northwest input on a second 3D VCA, which is sending this complex mixture of LFOs to 4 different modulation destinations. Among those, we have the mutable instruments plats in wavetable mode. That sort of emulates the classic wobble bass maker massive. Then we have the audio from that going into our mutable blades, which is doing our low pass filtering and some wave folding and things of that nature. And then we have the 2 filter outputs from blades going into our 3D VCA, which is being crossfaded in order to switch between the 2 filter outputs and to do that with the modulation that we're sending out. So I'm going to go ahead and turn up the volume. You can hear that we have some modulation happening, but if I turn down the slider on either of these VCAs, we turn off the modulation completely. And then if I change the X or Y settings on the second 3D VCA, we can get different ways to have our LFO mixture affecting different parts of our patch. And then if I change the X or Y settings on our first 3D VCA, you hear that modulation pattern starts to change. All the way from our fastest LFO to our slower LFOs. I'm going to go ahead and add in some drums. We can get all the way from something pretty nasty like this to something fairly subtle like that, just by messing with the 3D VCAs. Right? Pretty interesting. So the best part about this is that, again, all of this is under voltage control. So I'm going to go ahead and grab the random gates from our cascading register, plug it into the X and Y of both of our, put some more gates in there, both of our 3D VCAs, and we'll start to get randomization of our wobble bass. Not just the modulation pattern, but also the timbre of the wobble bass is being randomized. So I know this is kind of a tongue-in-cheek example of using CV with 3D VCA, but I honestly think it's a pretty good example of the sorts of things that you can do when using 3D VCA for modulation, and to really show an example of how it's not just for audio. Can you believe all of the things that 3D VCA can do? It works in mono, stereo, and quad. It works with audio, CV, and sequences. It could be a mixer, crossfader, or a panner, and often do multiple of those things at once. That's a lot for such a small module to do. Imagine everywhere that you use a VCA in your setup, and now imagine how much potential it would unlock to add 2 dimensions of complexity to those VCAs. So enter a higher dimension of sound with the Mystic Circuits 3D VCA.